So we've been talking about slope, intercept form, standard form, and slope for a couple of weeks now. And now we're going to shift our focus and start doing some application problems. So you need to have out your linear equation word problem notes for today. Now today we're just going to focus on word problems that would be best used with slope-intercept form, and then we're also going to do some that would be best to use standard form. So we're going to start out with some slope-intercept form word problems. Now one of the things that I want you to pay attention to tonight as I'm talking and as I'm teaching and as you're taking notes is how to tell that you should be using slope-intercept form, because obviously they're not going to tell you, hey, why don't you write your equations in slope-intercept form for this word problem? So it's going to be a mixed review where you have to figure out what's best. But right now it's going to be separated for you. So we know that slope-intercept form obviously is going to give us our slope and our y-intercept. So it's going to be best to use when you're given a rate of change. Now remember, your rate of change is the same thing as m, and remember, rate of change is another word for slope. Okay? And then also, if it's giving you a starting point, and a starting point would be like B, and if it's where you start, that's going to be your y-intercept, because x is going to be 0 at that point. Okay? So remember, slope-intercept form is y equals mx plus b. Okay? So that's just a little review. And now we're going to go ahead and get into this word problem. So look at number 1. It says, you and your friends plan to attend the county fair this weekend. The admission to the fair is $5 and the cost per ride is 50 cents. If your parents gave you $20, write and solve a linear equation to find out how many rides you can go on. Okay, so there's a lot of information here that's going to be usable for us. So the first thing that I'd like you to kind of key in on is that they were nice, they told you what they wanted you to do. They want you to write and solve a linear equation to find how many rides you can go on. Okay? So you're writing and you're solving. Okay? So we know that we're going to be talking about an x and a y value. So we kind of need to figure out, well, what are those variables really standing for in this equation? So when you read, it says that the admission to the fair is $5 and the cost per ride is 50 cents. And then your parents gave you the $20. Okay? So step 1, let's go ahead and write our equation in the form of y equals mx plus b. So did they give me a rate of change? Well, it told me right here that cost per ride is 50 cents. So your cost per ride would be your rate. It's how much they're charging for each ride. So 50 cents would be my rate of change. And that needs to be multiplied by whatever your x value is, which we're going to talk about a little bit more in just a second. Then up here, it told me that the admission to the fair is $5. So in class last week, we talked about that a starting fee or a setup fee or an upfront fee, something like that, that's when somebody is charging you something before they provide services. So here, just to get in, it's $5 before you do anything. So that is your y-intercept. That's the amount you have to pay up front. Okay? So I have my equation. I have y equals 50 cents times x plus 5. So now the question is, well, what is x and y? So your x, if you go back to the part of your equation where it talks about your cost per ride, so it's 50 cents for every ride. So your independent variable, or your x value, has to be where you input your number of rides. Okay? So here we were writing and solving a linear equation to find out how many rides you can go on. Well, if I'm doing 50 cents times the number of rides plus 5, then y is going to be representing my cost. And that's your dependent variable, okay? Because it depends on how many rides you ride, how much money you're going to spend, okay? All right, so they gave us some more information in here. They told me that the parents gave you $20. So if your parents gave you $20, then that's the most you can spend, obviously. Okay, so I'm going to go ahead and substitute that $20 in for my cost, because that's the amount of money that I have. And then I'm going to set that equal to my 50 cents times x plus 5, because I want to know how many rides I can go on. So I'm looking for x, the number of rides. Now I just have a regular equation like the ones that we've solved all year. So in order to get x by itself, the first thing I'm going to do is subtract 5 from both sides. When I do that, I'm going to get that 15 is equal to 0.5x. Then the opposite of multiplying by 0.5 is dividing by 0.5. And whenever I do that, 15 divided by 0.5 is 30. So I find out that x is equal to 30. So what does that mean? Did I answer my question? So the question was to solve a linear equation to find out how many rides I can go on. So if x is 30 when y is 20, that means if I have $20, so let's interpret this down here. If I have $20, I can ride 30 rides. Okay, so it's important to go back and look at your problem to make sure you're answering the question that is being asked. So I can ride 30 rides for $20. Okay, so that was a lot. There was a lot of stuff going on in that problem. What I'd like for you to do right now is I want you to go ahead and pause the video, and you're going to work number 2, and then I want you to restart the video and check your work with mine. Okay, so this problem was similar but slightly different than the last one. So when you read your problem, what you figured out was that the Rangers were charging $6.50 per hour. So notice, once again, up here we had cost per ride as our rate, and down here we have our cost per hour that's going to be representing our rate of change or our slope. And then in addition to a $25 deposit to rent a canoe. So there's my upfront fee, there's my startup or my y-intercept, so that's why the plus 25 comes in. So I wrote my equation, y equals 6.5x plus 25. So my y would be representing my total cost, and my x is representing the number of hours that I'm going to rent my canoe. So if you continue reading your problem, it says, if you wish to rent the canoe from 12:30 to 3:30 p.m., so that'd be 3 hours, because from 12:30 to 1:30 is 1, 1:30 to 2:30 is 2, 2:30 to 3:30 is 3. So for a total of 3 hours, we solved our equation to find the total cost. So once again, here my total cost was y. So this time, I was substituting in the number of hours. So I had 6.5 times 3 plus 25. And then whenever I do that computation, I find out that it would be $44.50. Don't forget to interpret your problem. So here I have it will cost $44.50 to rent a canoe for 3 hours. Okay? All right, so there are 2 more problems on this assignment that deal with slope-intercept form, but I would like to save those and talk about them in class tomorrow. So I want you to read them and kind of be familiar with them. If you're able to set up your equations, go ahead and do so, and then that will give us a starting off point in class. But let's go ahead and talk about some standard form equations. Okay, so you're going to use standard form, which remember is ax plus by equals c, where a and b do not both equal 0. You're going to use this when the problem relates two different objects. So when we were talking about slope-intercept form, we were talking about, a rate of change, and then we usually had like a startup fee, or we had some upfront cost, or we had a starting point. In this one, you're not going to really see that rate of change and that starting point. You're going to be talking about two different objects, and you're trying to figure out something about them. For example, in this problem, it says Sam ordered 2 tacos and 3 enchiladas for lunch at the restaurant. His bill came to $7.80. If enchiladas were $2 each, write and solve a linear equation to find the cost of each taco. So I'm really focusing on these first two sentences to start with. So I know I'm talking about tacos and enchiladas. So I know that that has to be what my variables are actually going to represent. So I'm going to use x as tacos, and I'm going to use y as enchiladas. So it will help if you go ahead and define your variables, just like we did back when we were writing equations, so that we don't lose track of what we're talking about. So I know that he ordered 2 tacos, and, so there's my plus, 3 enchiladas. And it says that his bill came to $7.80, so that means that together that had to cost $7.80. Okay? So notice this is in standard form. I have my ax plus by equals c. Okay? But then they gave me some more information. They told me over here that enchiladas were $2 each. So I already know the value of x. No, I don't. I know the value of y because it said enchiladas were $2 each. So that's why it's important to write this down. So I know y represented enchiladas. So I'm going to go ahead and substitute the value that they were $2 each into my equation. So I know that I have 2x plus 3 times 2 equal to $7.80. Now what I'm trying to find out is, well, how much do tacos cost? So I'm going to go ahead and solve this equation, and that'll give me the value of x. So step 1 is to simplify, so I have 2x plus 6 equals 7.8. I got that 6 because that is what 3 times 2 was equal to. The next thing I'm going to do is subtract 6 from both sides. So whenever I do that, I am going to get 2, I'm going to bring down my 2x. These are going to cancel, and then I have $1.80. Then the opposite of multiplying by 2 is to divide by 2. And whenever I do that, I'm going to find that x is equal to 0.9. Now, I'm not just going to leave this as x equals 0.9 because I want to go ahead and answer the question that was being asked. And the question was, what is the cost of each taco? So I'm actually going to write out that each taco costs 90 cents. Okay? So if you look at this problem, there were 2 tacos at 90 cents each and 3 enchiladas at $2 each. And if I did that math, it would equal $7.80, which was the cost of his bill. Okay, what I'd like for you to do is go ahead and pause, and I want you to work number 6 on your own, and then restart the video and check your work with mine. Okay, so if you look at this problem, we were comparing tickets that were sold in advance to tickets that were sold at the door. So that's how I knew how to use standard form. So I went ahead and assigned my x value as tickets sold in advance, and my y was going to be the tickets that were sold at the door. So it was $4 in advance, so that's where I got my 4x, plus $5 at the door, so that's where the 5y came from. And it said that total ticket sales were $440, so that's why it equaled 440. Then here it says that no tickets were sold in advance. So if no tickets were sold in advance, that means that x had to be equal to 0. So I substituted a 0 into my equation for x. When you go to simplify, 4 times 0 just cancels out. So I just brought down my 5y and my 440. Then the opposite of multiplying by 5 was to divide, and I found out that y was equal to 88. So going back to my question, it says how many were sold at the door? Well, if they didn't sell any in advance, then they had to have sold 88 at the door. All right, so once again, there's 2 more problems left that will help us practice standard form, but I would like to look at those in class tomorrow. So if you would, go ahead and read them and see if you can set up your equations, and then we will start there tomorrow. You guys have a fantastic evening.